Hi everyone, in this video I want to talk about classifying parallelograms, specifically here on a graph. And here's the one problem that we'll do. We're not going to do two since we want to dive into this larger one. To make sure we don't take ourselves too seriously, think about the fun question. If you had to pick a new language to learn, which would you pick? So on the math section, this concept falls under geometry. It not only involves coordinate geometry, but also polygons on that coordinate plane. I've seen problems like this before. Sometimes they will ask you for one of the coordinates of the vertices. Other times you'll just have to classify the shape. So in this case, it's asking you, is this a parallelogram? So what I recommend doing first is drawing a graph and just making nice even tick marks on each side. Notice my graph it's not perfect. This is a minute per question for each of these. So I'm doing this in a, not so perfect way, trying to be as accurate as possible though. So 2, 2 right there. 3, 4 would be over 3 up 4. Then 6, 4 would be over 6 up 1, 2, 3, 4. 5, 2, 5 up 2. Okay, so with my rough sketch, this does look like a parallelogram. Okay, now that's just rough, but you know that the ACT is it gets very specific, and so you really have to prove yourself with some work. So what is a parallelogram? Well, opposite sides are congruent and parallel. Okay, so if that's the case, then there are a few things that we could do here. We could go the congruent route. Okay, we could talk about congruency, or we could talk about the parallel aspect. What I recommend, so let's think about, if I went the congruent route, that would mean distance. And if we went the parallel route, this would require like the slope formula. Well, what I could do to check slope real quick, and let me change colors, is I could just make sure, obviously these two slopes are the same because they're parallel on the horizontal axis. But I could make sure that my rough slope would be the same from, point A to point B here. So if I'm going over 1 and up 1, 2 units, then that would be, remember, it's rise over run. So that's a 2 over 1 slope, 2 over 1, up 2 over 1. And then this also is up 2 over 1 for this. The opposite side across from it. So I know that based on slope, it definitely looks like a parallelogram. Okay. I could also talk about distance, remembering that I'm kind of rushed under that 1 minute time restraint. I could talk about distance. I could find the distance between this point and this point by just plugging them into the distance formula. Just a reminder of what that is. There is a video on this. It's x2 minus x1 squared plus y2 minus y1 squared. And when I say x2, I'm meaning x subscript 2. So we could check that. But like I said, you could do either distance or slope. If the slopes are the same, you don't even really have to check distance. Just for kicks though, the distance right here to on the horizontal lines, we can just count units for that. Okay, so this is 3 in line with the 3 here, and this point right here would be in line with the 6. So I know that if I have 2 points on the same horizontal axis, I can just count spaces. So that's 3 units over, 3 units over. So it seems like if I know the slopes, we could do kind of a hybrid here. We'll do the slopes of 2 of them and then the distances of the others. Because I proved that the slopes of these lines that are parallel are the same. And we know that the slope of a horizontal line is 0. That would be 0 and 0. That would tell me that just based on the slopes, that is a parallelogram. We can bring that number 3 back. This is 3 units long. Okay, this top and the bottom. And then we could also use the distance formula to find the other line, the other set of lines as well. So it's up to you using distance or slope. What I think you might want to work on is the more common question that I've seen on the ACT, and that is figuring out if you're given 3 vertices, what is the 4th? Okay, so we have 3 given. You would draw them out and try to figure out the 4th point. I've seen this exact problem on there before, and just note that your answer choices are all going to be very similar. Like, they're not going to be all strewn across the graph. They're all going to be very, very close to each other. So you really need to know your stuff in terms of either the distance or slope formulas for this. Just think about the fastest way to do that problem. And just to note, for this one, if it was a yes or no question based on our slopes, I just want to make it very clear that this answer would be yes. That this answer would just be a point, whatever that 4th point is. Why don't I pause the video so you can try this and I'll reveal the answer. All right, the answer for this one is 1, -3. And if I were to guess the other options on this problem, I would think another one would be like 2 and -4 or 0 and -2, something very similar to that 1, -3. So just be careful of those, what we call distractors. So a quote to leave you with a little bit of motivation. This is by Drew Barrymore. Life is very interesting. In the end, some of your greatest pains become your greatest strengths. I have found this to be very, very true. So I hope this video helped you in some way, and I would love to see your answer to the fun question in the comments. Feel free to subscribe if you want to keep up with new videos. Have a good day.